Hello everyone, myself Assistant Professor Vatsal Patel from Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center NAVSARI. Today we are going to discuss about plane table survey. So be ready with your pen and paper. So our today's topic is 2-point problem. So in this problem, two well-defined points whose positions have already been plotted on the plan are selected. Then by perfectly bisecting these points, a new station is established at the required position. Okay, so let us understand this problem with the help of this figure and this method. Okay, so suppose here capital P and capital Q are two well defined points whose positions are plotted on a map as small p and small q. Okay, small p, small q. So it is required to locate a new station at say station A here. Okay, capital A, by perfectly bisecting the points P and Q. Okay, so an auxiliary station B is bisected at a suitable position. So here B is there, station B is there, capital B. So the table is set up at station B and labeled and oriented by eye elimination, and it is then clamped. Okay, so with LED touching small p and small q, the point P and Q are bisected and rays are drawn. Okay, so here we can see rays are drawn here also. Okay, so suppose these rays intersect at point B. Okay, so we have already drawn the rays from station B to connect these 2 points, and what point they intersect we term as small b. Okay, so with LED touching B, okay, the ranging rod at A is bisected and a ray is drawn. Okay, then by eye elimination of point A1 here, a point A1 is marked on this ray. Okay, so the table is shifted and center on A. Now what we have to do? We have to move table to the station A. Okay, and with A1 just over A. So we have to establish a table as the A1 points here. The A1 points come exactly over the station A. Okay, it is labeled and oriented by back sighting with the LED touching small p here. Okay, small p. Okay, the point P here, capital P, is bisected and a ray is drawn. Okay, a ray is drawn. Suppose this ray intersect line BA1 here, BA1, small b A1. Okay, at point A1. Okay, at point A1 as was assumed. Okay, it is assumed. Okay, now with the LED centered on A1, point A1 here. Okay, the point Q is bisected here. The point Q is bisected and a ray is drawn here like this. Okay, suppose this ray intersect the ray BQ. The ray here is drawn already. Okay, BQ, the ray, this ray. Okay, at a point small q1 here, q1 point is given. Okay, so when they intersect, okay, it is termed as q1, small q1. So the triangle, with triangle p q and q1. Okay, so this area is the triangle. Okay, so the triangle p q and q1, okay, is known as the triangle of error, and it is to be eliminated. Okay, so here is the triangle which is of error due to some error. Okay, so it should be eliminated. Okay, so the validate is placed along the line PQ1. Okay, PQ1, and ranging rod at R is fixed at some distance from the table. Here you can see, here a ranging rod is fixed at some distance from the table. Then the validate is placed along the line PQ, here P and Q, small p and Q, and the table is turned to bisect R, capital R. At this position, the table is said to be perfectly oriented. Okay, so orientation is done. So finally, with the validate centered on small p and small q, the points P, capital P and capital Q are bisected and rays are drawn. Suppose these rays intersect at a point A, here, point A. This would represent the exact position of the required station, capital A. Okay, so first of all our station is here. Okay, say it is. But after applying all the correction and method, we get the point, station and point exactly on the same line. Okay, so then station A is marked on the ground, and then station A is marked on the ground. Okay, so you can write all the procedure step by step from here. Okay, so I have already explained all the procedure, so you can write it from here. Okay, all the procedures are mentioned here. So next we are going to discuss about 3-point problem. So in this problem, 3 well-defined points are selected whose position have already been plotted on the map. Then by perfectly bisecting these 3 well-defined points, a new station is established at the required position. No auxiliary station is required in order to solve this problem. This table is directly placed at the required position. Okay, so there are mainly 3 types, or say 3 methods. The problem may be solved by following 3 methods. So which are namely BESSEL'S method, mechanical method, and the trial and error method. So let us see the BESSEL'S method first. So it is also known as the graphical method. Okay, so let us understand the graphical method, or say BESSEL'S method. So suppose capital A, capital B and capital C are 3 well-defined points which have been plotted as small a, b and c. Okay, so now it is required to locate a station at P. Okay, so first operation is done. Now we have to locate a station P. Okay, sorry. So the table is placed at the required station P and level. Then the validate is placed along the line CA, here line CA. Okay, and the point A is bisected. Point A is bisected. The table is clamped with the validate in center on C. Okay, the point point B is bisected and a ray is drawn. Sorry. Okay, so again the validate is placed along the line AC and the point C is bisected and the table is clamped with the validate touching A point. Okay, a point B is bisected and a ray is drawn. Okay, so suppose these 2 rays. Okay, so rays are drawn. Okay, so third operation is here. Okay, so suppose this ray intersect a previous ray at any point D. Here point D is mentioned here. Okay, so we have drawn all the rays, and this ray intersect at previous ray at any point, so which we have to term as small d. Okay, or say point D. So the LED is placed along line DB. Okay, here is line DB. Okay, and point B is bisected. At this position, a table is said to be perfectly oriented. Okay, now the rays capital A and small a. So okay, capital B and small b, capital C and small c are drawn. Okay, so all the rays are drawn. Okay, here. Okay, so these three rays must meet at a point P. Okay, so point P will be here. Okay, so which is the required point on the map, and this point is referred or say transferred to the ground by UFORC and plumb up. Okay, so by this method the station point P is marked on the plane by this method. Okay, so this is the graphical method. Okay, so here is the procedure, so you can write down it step by step procedure from here. Okay, next we are going to discuss about the mechanical method. Okay, so suppose capital A, capital B and capital C are three well defined points which have been plotted on a map as small a, small b and small c. So it is required to locate a station at P. Okay, so our station is here, so we have to locate a station at P. So the table is placed at the station P and level. Then a tracing paper is fixed on the map and a point P is marked on it. Okay, so we have to place tracing paper here. Okay, and mark it as a point P. So with the LED centered on capital P, say point P. Okay, here points A, B and C are bisected and the rays are drawn. Okay, so all three rays are drawn. Okay, this ray may not pass through the points small a, b, c. As we can see in the image, the rays are not passing through the point A, B and C. Okay, so as the orientation is done approximately, so orientation is done here is approximately. Okay, so the rays are not passing through these points. Okay, so now a tracing paper is unstiffened and move over the map in such a way that the three rays simultaneously pass through the plotted position A, B and C, small a, b and c. So in this image you can see the tracing paper is set according to that the rays are passed to point small a, small b and small c. Okay, then the point P is pricked with a pin to give an impression of P on the map. Okay, and the capital P is the required point on the map, and the tracing paper is then removed. So then the LED is centered on point small p and the rays are drawn. Okay, so rays are drawn, okay, towards A, B and C. This ray must pass through the points A, B and C. Okay, so this is the mechanical method. Okay, so here you can see it's all procedures. Okay, we have already discussed it. Next, the method of trial and error. Okay, so suppose capital A, capital B and capital C are the three well defined points which have been plotted as small a, b and c on the map. Now it is required to establish a station at point P. Okay, so point P is here. Okay, so the table is set up at P and level. Orientation is done by eye estimation. Okay, so with the elided ray is capital A, small a, capital B, small b, capital C and small c's are drawn. Okay, so all the rays are drawn. Okay, so as the orientation is approximately, the ray may not intersect at a point but may form a small triangle of the triangle of error. Okay, so here triangle of error is there. You can see all the points are not exactly intersect at one point. Okay, so we can see in the image A dash is here, A BB dash, sorry, not A dash, small a and capital A, small b and capital B, small c and capital C. So here we can see small triangle of error. Okay, so let's zoom it out. Okay, so here is the triangle. Okay, so these rays are not intersecting. Okay, and form a triangle of error. So to get the actual point, this triangle of error to be eliminated. Okay, so by repeatedly turning the table clockwise or anti-clockwise, the triangle is eliminated in such a way that the rays, say capital A small a, capital B small b and capital C small c, okay, finally meet at a point P. Okay, so finally they will meet at point P. Okay, so this is the required point on the map and this point is transferred to the ground by U-fork and plumber. Okay, so here is the procedure of it. So you can write all the steps from here. Okay, so next we are going to discuss about points to be kept in mind in plane tabling. Okay, so the following points should be kept in mind while doing plane table survey. So ground point shall be marked as capital A, capital B and capital C, etc. And plan point, say on paper, shall be marked as a small a, small b and small c, etc. Okay, already we have seen it in all the method. Okay, we have marked all the station ground points as capital and plan point as small. Okay, the rays from survey station to the object shall be drawn by dashed line. It is also we have seen in the image. Okay, sorry. The elidate should be properly pivoted while sighting the objects. Okay, while establishing magnetic north on the paper using true compass, things causing local attraction shall be kept away of the table, like some rods, steel bars, which may create a magnetic field. Okay, so we have to remove this local attraction before the process is start. Okay, the plane table should be clamped after centering and leveling, and the table should be rotated at the time of orientation. So it is the main point. So be sure in mind you kept all these point in your mind while you do the plane tabling. Okay, now we are going to discuss errors in plane tabling. So the various sources of error may be classified as instrumental errors, personal errors and errors in plotting. So first of all, let us see instrumental errors. So the top surface of the plane table is not perfectly plane. If the top surface of plane table is not perfectly plane, then there are chances may miss some points. Okay, and some rays. Okay, the fiducial edge of the elidate might not be straight. If we are using elidate to draw the rays, okay, and its fiducial edge is not straight, then it will not make the perfect lines. Okay, the fittings of the table and tripod are loose, like where in the process of orientation. Okay, if some error may be due to the fittings, okay, the table may loosen up. Okay, tripod stand or leg may slide. Okay, so the fittings of table and tripod are loose, then this may happen. Okay, the needle of true compass may not be perfectly balanced, and also it may not be able to move freely due to sluggishness of the pivot point. The side vanes are not perpendicular to the base of the lead. Okay, next the horsehair may be loose and inclined. The level tube is defective. The drawing paper is not of good quality. The fixing clamp is not proper. Okay, so these are all are the instrumental errors. Okay, so we have seen the instrumental errors. Next is personal errors. So the plane table is not properly leveled. The plane table is not accurately centered. The orientation of table may not be proper. The table is not properly clamped. The objects may not be correctly pivoted on the station point. The rays drawn by LED are not correct. The LED may not be pivoted on the same side of the station point throughout the work. Okay, so these all are the personal errors. And the last one is errors in plotting. So an incorrect scale may be used by mistake. A good quality pencil with a very fine pointed end may not have been used. Errors may occur due to incorrect measurements from the scale. Plotting error may occur due to unnecessary hurry at the time of plotting and adopting wrong method of plotting. Like if we talk about scale, if we are taking a scale of 1 centimeter is equal to 1 meter, okay, and by mistake we take it 1 meter is equal to 1 centimeter is equal to 2 meter, then all the scenario will be changed. Okay, okay, so this error is done due to the plotting. Okay, so here are the important questions which can be asked in your examination. So we have already discussed all these theories. Okay, so write down all these questions, it is important for the exam. Okay, so here I end my session. Thank you all of you.